Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility, so this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows.
Super, and today's focus incident is going to be a global Azure Front Door, or we'll refer to it as AFD issue, that occurred on the 29th of October. This follows one that recently happened on the 9th of October, but this was different in that bad metadata propagated throughout our own edge sites and it failed the checks that kind of go from stage to stage. Following mitigation, which took about 8.5 hours, we put additional restraints on the AFD service to restrict customers changing things temporarily. For customers, this was very painful, and it was almost like an orchestrated outage.
That's right. Great way to think of it. That's like the two-line summary, but we'll get into a lot more detail about today. So to get that started, I'd like to introduce the engineering leader joining us on our panel today. To my left is Abhishek Tiwari. Abhishek is our Vice President of Software Engineering for Azure Front Door, which is the main service we're going to be talking about today. Abhishek, thank you for joining us.
Thank you for giving me this opportunity. Before I start and then we go into the interacting in this session, I want to apologize the pain and impact it caused to all Azure and Microsoft customers. You all have taken a trust on Azure and running the critical workloads, life and safety workloads, and having an impact like this broad, it's definitely painful, and we would do everything to make sure it never repeats. And in this session, you'll discuss some aspects of those. Thank you.
I'm really interested to get into this. But before we start talking about anything, perhaps you could talk to us and our customers about how Azure Front Door service is used, both internally and externally, what changes we make to these control planes, and, and how these changes are typically made.
Okay, yeah, so first start with the Azure Front Door. Azure Front Door is our globally distributed edge services. It runs more than 300 locations across the world. Some of the assets on the serving side runs within Azure data centers, outside Azure data centers. We sometimes refer as edge sites or POPs. Like any distributed service in Azure, it has different layers. It has a management layer where customers make changes using Azure portal to the service, and then it takes the configuration changes and then process to the internal system metadata that we call it Azure Front Door control plane. And then we have this data plane that's actually serving the customer request, HTTP and HTTPS request to their application endpoints, and that's data plane distributed across the edge sites. It's typically used to provide acceleration, caching of the content delivery across making sure user experience is optimized, and then for the latency sensitive application. We also provide a protection for application, which is a WAF, DDoS. So it's a critical service, and it's fronting the application between user and application workload. So any interruption here, it's really, really impactful. And in any case a degradation happens, the users, the customers who are Azure Front Door customer, their users won't be able to connect to their applications.
Super. And then when we talk about the control plane, we make updates to our control plane on a regular basis? Or?
Absolutely. Like in the large distributed service, we make constant releases to every layer: management plane, control plane, data plane. So yes, each of the Azure release follows the safe practices. We call it SDP. It gets deployed very slowly in a fail unit by fail unit, and it's enough bake time. But that process happens very routine in a periodic manner, almost every week, sort of, if we could say.
Abhishek, you mentioned briefly these customer configurations and how they propagate to these edge sites. Can you give us some real-world examples of what these configurations are? Because I also want to understand, it seems like we're pulled in these two different directions, right? We want these customer configurations to deploy quickly. We want them to propagate to all edge sites because it's a global service, and we want that consistency everywhere.
Right.
But we also want them to propagate slowly so that we can make sure that it's not introducing any new issues. How do we reconcile those two?
More than slowly, we want to propagate propagate them safely.
Right.
So yes, example of Azure Front Door, customers who are using Azure Front Door, making policy changes. It could be a cache purchase where it's compliance issues. They want to remove some of the cache data that's being served to the users. It could be for any reason. And then usually on those parts, it has to be the quick action. So once the customer initiates the change through our portal or through our arm, we want to make sure this cache content anywhere in the world gets cleaned up within minutes. Other changes are if the application is under DDoS attack, and then as a customer, you are crafting a WAF policy, you want to deploy that WAF policies as soon as possible to protect your workload. Otherwise, it's getting exploited, it's getting a denial of service, and sometimes if application go in a bad state, it takes a long time to recover. Route changes, bringing your scale out or scale in operations of the workloads. These are the operations customers prefer to get deployed quickly. And since their users are connecting across the globe, it has to be available every part of the Azure Front Door fleet. So that's why it's a fast and it needs to get deployed everywhere. So it's, in that sense, it's a global nature. None of our own internal infrastructure, metadata or data for the service itself gets deployed that fast. We have this a sort of control to roll it out slowly, but for the customer ones, given that expectation and given that the criticality of nature of these changes, it has to deploy globally and has to deploy rather quickly compared to the other deployment. We do it in Azure. That's what we do here. Is that I cover all the aspects of your thing? Yeah.
Incredible just to hear about the trade-offs, but we have to prioritize speed in a service like Azure Front Door. If we fast forward to the 29th when the incident happened, we mentioned in the PIR, it was a very specific set of customer configuration changes that introduced some of these issues. And we clarified that it wasn't malicious or there was no bad intention. How common is it for, number one, for customer configurations to be on two control planes, if I understood it correctly? Is that a common practice, and was it a very specific sequence of events?
Yeah, no, actually, I want to clarify, and I know that some of the feedbacks we get in the postmortem, a small feedback on our PIR is about this. So it's not a same customer or set of customers configurations are on two different versions. It's the timeline of the changes that customer or set of customers were making. So assuming we do this control plane and management releases very frequently, and customer in a timeline series A made some changes to their Azure Front Door profile. At that time, the Front Door control plane was running, say, version X, and then the customer made some changes a week later, and at that time, Azure Front Door control plane version has upgraded to B or C, and depending upon what's the gap on the changes made by customer and it's their requirement, you could end up having some set of changes made on a version of control plane, and then depending on time B or the later version of control plane, and that happens all the time. It's very regular in any control, whether it's you use ARM for portal, you make a change, and then sometime later you would be using a different version of that interaction at this scale of service.
That's great to understand that specific sequence of events. And so that, was, like we said, wasn't malicious or anything like that, but coincidentally, because of those different control plane versions, that introduced this bad metadata. And we've mentioned bad metadata a few times. Can you help us to understand what that metadata is and how we missed that it was bad? Like, we're going to cover some of our validations and checks. Did we not realize that the metadata was bad before it propagated?
After the outage, it seems definitely points out we could do more on our shift left or doing a validation before shipping changes in production. But in this case, just dig a bit deep on what has happened. In this case, it's not a corrupted metadata. In Azure Front Door profile, when the internal service taking those changes and generates the metadata for the customer changes, some of these objects have references based on the policies. For example, you have a WAF policy would be referred by your profile. So these references are put into a data plane because ultimately this state gets deployed into data plane, and data plane takes, in this special cases, references what all objects in configuration referring to a object. And in this case, what happened, the reference count that we had and a change in the control plane system, we ended up having a reference leak, which means a data of this config data and data plane got removed or changed without realizing it's still being referenced by some part of the data plane processing. And when that happens in the system like this, it's not a coding state where you would realize, oh, I'm having this and it's no longer there, let me fall back. It ends up resulting like a memory corruption, or you pointing to a space in OS that you have validated and assume it's to be there and it's no longer there because it was changed not in that context, but some other background context. And in these scenarios, it's results into a process crashes. And in this case, this is the exact thing happened. The incompatibility of the metadata reference operations count, not necessarily the metadata values itself being corrupted.
It's great to understand that the crash a bit more. It's good to understand the detail behind that, but I'm particularly interested, that crash didn't happen immediately. Is that how it was able to propagate? Because we check, we validate for health signals,
yes,
and things were healthy, right?
So this is where, we would discuss a bit more. In global service like Azure Front Door, where the state of these configs has to be replicated across the fleet, we know the risk. If there is a challenge or a SPOF or issue in this, it would be of global impact. And precisely to prevent these, we have a config guard or config protection system. What it does, it checks, and this config is, though it's deployed between 5 to 10 minutes across the fleet, every stage we check the feedback from data plane, positive feedback that it has received and processed before propagating to the next stage. In addition, we also check a global view of our site's health, so that if any broad changes like crashes and data plane going down reported, it also stops propagation or further propagation of any configuration changes. So those two protection systems protect us. In this case, the reference miscount or leak that happened asynchronously.
Okay.
So we have put this reference cleanup or removal of the reference because it's no longer used. This object is still there. It's through a background processing. And data plane, when it loaded the configuration, it provided the positive feedback. In our global view of the system, we watched the health of those edge sites. They remained healthy. And that led us propagate to the multiple stages before they start showing the symptoms of a crash. And in fact, at that point, a global protection on the config system blocked all the deployment propagating. It blocked, but it was too late for this case. It has already passed most of the threshold. It have already received a positive feedback, more than 80% of our fleet. And 80% in Azure Front Door capacity is a large number. So given that situation, despite us having this late, which happened around the 6th minute of the configuration propagation starts, and given our timeline to deploy everything, it's usually complete between 5 to 7 minutes, but we say 5 to 10 minutes, it was almost complete to the entire fleet. So that's where our configuration protection system, it let go through. It was not bypassed, but it let go through this incompatible changes, which would cause a crash or cause a crash, and didn't realize this asynchronous nature of our baking period and timing. And that was definitely a mistake on our side, a learning on our side. And we would fix and then take holistic approach out there.
So as you talk us through this bad metadata there and the AFD service is impacted, we've been speaking to customers, to support engineers, to account teams. And even on that day, we saw this in the media being picked up. Could you talk us through what customer pain would have felt like? What would have customers experienced, both from a first-party point of view, because Azure was also impacted, but also from our end users and our customers? What did their experience look like?
So there would be two categories of customers impact. The first category, which is probably obvious to the customer, that their front door profiles and front door application, not application, but front door applications behind front door not working, because these are the set of customers who have onboarded to front door, they have onboarded their applications. So it's a large number of customers who get impacted, and then the impact varies where their end users cannot connect to their applications, or it's super slow, depending upon the which recovery time we were in, very high latency, connection failures, timeout. In this case, another symptom that came, Azure Front Door runs its internal DNS system, which it uses to route to which edge sites and then make few of the load management decisions. Given we were crashing an entire Kubernetes pod that's on the restart path, the DNS resolution at the end for the Azure Front Door hosted CNAMEs and those records were failing, which reflected as a DNS failure. That created some confusion to the field, to the down detector, that it could be related to a DNS failure, but it was not. It was a Azure Front Door data plane having availability issues. So that's like obvious set of impact. The second impact is for the first-party services that onboard to Azure Front Door. And the users of those first-party services are not exposed or aware of this fact that these services are using Azure Front Door. And in that case, it also creates some, if we don't communicate in timely manner, and if we don't update our internal services to this fact, it basically creates a confusion. Impact is the same. These end users of those applications will not be able to access. So for example, in this case, Azure Portal, it would be unavailable for all Azure users. Intune and Portal or Entra Portal that are part of Azure Portal extensions will not be accessible. So, but in this case, its customer cannot directly see their side of resources health being down or red, and that all relies on the service owners on our side communicating and then providing update on this. Yes.
That's a good summary, but I mean, this seems hugely impactful, like multiple services,
Yes.
multiple regions. We know this was a big deal.
We recommend Azure Front Door for the application protection, and we do that same recommendation for our internal first party, critical first party, as you have seen in this incident, including our critical support services were impacted. And the precise reason, these are internet-facing services, and they are also vulnerable for different L7 attacks, and then Azure Front Door is providing protection layer or edge layer for this. So yes, it was quite impactful.
Right. So I mean, good reasons to have things behind Azure Front Door, but bad when something like this happens.
Yes.
I'm interested to understand, could you talk us through the incident management on the day? So how did we detect what was happening? How did we investigate it? And especially, I'm interested to understand how we mitigated it, because in the post-incident review, we talked about, hey, we've got this last known good, we've got this snapshot over here, but we chose not to use it. We weren't sure whether we trusted it. Can you talk us through some of those kind of trade-off decisions that were made? And I guess the real question is, what took so long?
Yeah, no, we'll cover. Start with the incident. Azure Front Door has a monitoring system that's also distributed across the globe. We have these probers part of our critical application that's probing all the global fleet of Azure Front Door. So as soon as the impact started, within minutes we knew. DRI gets engaged. We have our internal system, we internally call it brain, but that's used to get those health signals and seeing those regressions automatically declare outage. So in this case, that has happened. So that part was good, where the DRI engagement and then degradation part, and then the updating our status part, that happened fairly quickly. But in this case, when we realized this is happening because of this incompatible metadata, or the change was made, it took some time. But given this massive impact and the situation, it was still like considerably okay to able to root cause. And that's where the challenge happens. Azure Front Door, for all the positive feedback changes received from the fleet, it puts into the committed state, and every 15 minutes it takes a snapshot of the good config, which we call it LKG. So every 15 minutes we take this LKG version, in which believe like, these are the ones where entire data plane has provided positive feedback. In this case, since the uncompatible metadata got all the positive feedback, when we halted the in-progress deployment, we halted the future ones and that were in flight. But this particular incompatible change made it to our LKG from the fact that it received positive signal. It was not in the automation, and that's where our config protection failure comes into place. And we were into 45th minute or hour limit, which means this change is propagated into the last 4 versions of LKGs. We had the DRI tooling to take back the fleet within a minute to any of these LKG versions. It's not we have to handcraft that. Those, being a service running this critical service, that DRI tooling, and without manually crafting those commands, it's available. The risk discussed there is a good amount of delta changes made it on the going back to 5 versions back on the LKG, that might overload the available pods. It's a very few pods that are available across the fleet that is still serving some traffic. And if we go this version, we might impact those healthy pods as well. So at that time, we made a decision, rather than taking a change to go back to the X versions back, we still use a DRI tool to make a change into the latest LKG version. So it's not we were like trying to handcraft certain things. There were tools available to modify the latest LKG. Of course, it took time for us to say, this is the tenant, these are the IDs, and that's the part we want to clean up. But once you provide those information to our DRI tool, it cleans and it deploys. But that took time, and that's why the decision in that situation, we have to make a call. I was on the incident managers for this incident, and I made that call to go and then update the latest version. We did not want to hamper our recovery. Then, sorry, one more part, but still we took around 4 hours to recover after this. And this is, we have about 750,000 of the applications that are onboarded on Azure Front Door. The system, after this pod warm boot, we call it, it was loading all the metadata of these the profiles or configurations. And there were, of course, inefficiencies in that processing, and it takes about 4.5 hours. That is a limitation we saw in October 9th outage, and we were aware of some of those inefficiencies that we could address in shorter span time, and we'll talk in that repair. But in this case, just loading up the metadata of this large number of profiles took about 4 hours. We start seeing recovery in 2 hours into the incident, depending upon the situation, but we could not mitigate the incident to the previous impact level until way late into the impact.
For our customers, the DRI is the directly responsible individual,
Right.
and that was the engineer that was on site. It's fascinating to say we don't want to go back too many versions, and we made a modification.
Right.
And it is incredible that we have the tools to make those slight
Yes.
changes before we reship that in.
Yep.
Following mitigation, and it was great, we started to recover, but then following mitigation, we imposed restrictions on customers. And
Yeah.
so we blocked all service management
Right.
operations. So effectively, we actually introduced an outage for customers for several days afterwards.
Yes.
While we were putting in
Yes.
further kind of resilience into our system, could you talk us through some of those decisions?
Yes, and that was, once we mitigated this outage, there was no known risk at that point that we were aware, and that's why we blocked the control plane. That was not the reason. We blocked the control plane because this has happened on 2 different bugs in a very short span of time. And we were aware, or we were from the first incident, like, knew there are short-term repairs that we could finish, and that would put us in a great steady state. And this is an exec decision we made to put the control plane operations on a block, not to have a recurrence for anything unknown. And then let's rally the entire team to finish up these repairs that we are working in past few weeks, in some cases past few months, and then finish this off. And the decision was, it's a very painful in Azure Front Door to block the management operations. For many customers, it amounts to a data plane impact or for their applications. It was a painful, hard decision. But when we released or unblocked it, we put the good protection and hardening in our system to be confident that the similar category will not happen. And that's what we did. And that's the reason we took that hard decision on blocking the management operation for the customers.
Good. Thank you for explaining the trade-off there to that additional pain of several days was worth it to justify making sure that we could get back online quickly. I'm interested to understand, look, we've mentioned the previous outage from 3 weeks earlier. Several of our customers have asked about the differences between the October 9th front door outage and the October 29th front door outage. So reading the post-incident reviews, we gather that these are different failure modes, there were slightly different bugs, but there was some overlap in the repair items. So what was similar and what was different?
So the failure mode, or we call it as a risk category, it's a similar risk category. It's a change of that needs to get deployed across the fleet, has some incompatibility, and that creates an availability or regression in our data planes. So in that sense, both October 9th and October 29th were same. What was different in October 9th, actually our config protection system worked. So when the incompatible changes reached our pre-canary stage and it's crashing the data plane system, config protection system blocked the propagation of it. And the config protection system worked because those set of incompatible changes were processed synchronously. It was not a background processing needed on those objects. So given that they were performed right away and then causing a crash, and both global level view and then the local level view, we were able to get the feedback, and then the deployment, the protection system blocked it. The outage happened later when a alert saying some of the config propagation for tenants are blocked unnecessarily, and DRI taking a task to clean up those metadata which bypass the config protection system. And October 29th, it's not the bypass, because in October 9th, there were 3 learnings. We should never ever bypass the config protection system. And that fix we did. There was not any path available to bypass the configuration protection system. But what we missed, whether config protection system itself has this gap that would let it go through. So that's the one major insight, a major difference. The second part was recovery took long in the October 9th. And same was the case with the 29th. We noticed this, we prioritized right away and working on it. And that's the whole reason we were able to ship in our entire fleet, which is 300 POPs, which usually take about 14, 15 days in a good scenario to roll out everywhere. We were able to complete that after 2 days of the October 29th outage. And we started at that time to make a change, validate, and then qualify the build. Itself is a 3 weeks plus process. So that means the common learnings we prioritize, and that's the reason we were confident that before we unblock our control plane, there are certain things we can definitely harden our system or make efficient our system. So there were common learnings like recovery. There were common learnings like the things on the DRI side we could do, but this config protection system having a gap in this asynchronous processing of thing was a miss for October 29.
Super. As we start to pivot to learnings, one of the things that's very interesting in our learning category is that we understand that outages are inevitable, but AFD being a global service means that you don't want to have these big blast radii outage, and you are making repairs to make them more cellular, granular. Could you walk us through some of these repairs?
Yeah, and I'll dig a bit more onto the cellular cellular architecture of Azure Front Door that we are working for past year plus. It's a major change for us. And we expect to release in first half of next year. But there were three categories of repairs or learnings, we could say. A, config protection system protects. It just doesn't matter whether you are a cellular architecture or not cellular architecture, but it protects from a bad configuration. So we made a set of changes. We introduced a pre-canary stage where it's only the production configurations are there, and then we are running our validations. We increased the bake time and then did few other hardening to ensure that never happens. So even if in this case, the worst case of asynchronous processing happens, or like some other unknown that we have not figured it out, it would protect us. That's one. Second category of repair is if a bad configuration gets processed by our data plane, it does not make crashes the active worker process or active master and combination of proxy that's like taking the customer request. It does not crash those. So we are calling this as an isolated on the every data plane pod, isolated set of process that's doing this processing of the config. And if it crashes, it will have zero impact on our availability. Customer might see the impact on the control plane changes not flowing, and which we should be able to recover quickly. And if that situation happens where our config protection system didn't work, so even in that case, it will never ever create a challenge to our data plane. We would be putting this very soon. The third category is microcellular architecture. Azure Front Door is running on the edge sites, and we don't have much capacity in those sites. At majority of our sites could be running 2 to 4 hardware racks. Serving 750,000 customers on those 4 racks, it's very difficult to partition in a physical hardware basis. It's impractical. Creating even virtualized partition is impractical. So the microcellular architecture we are doing is we are using a ingress sharding technique, and we'll publish a blog once it's out, where consider this is one of our EVP, Charlie Bell, described this. Consider this as a pack of cards where I shuffle the card and I give a set of cards to you and to you, to me. The chances of 3 of us having the same card is very, very low. And the same thing we are doing, we have 24 to 48 workers per single node. And among 2 to 4 racks, if we start distributing this shuffling of the tenant responsible to taking those requests, a single tenant impacting any other tenant, even in it's taking down our data plane, the impact to the other at a single site level is 0, close to 0. And when you take a look of our global fleet or geo in say like North America or USA, that level, it's like not even creating a challenge to our 5 nines SLA. So that's our microcellular architecture we are investing on, and that would ensure regression caused by a tenant config. It's not a customer fault. It's our defect that's like making, or the traffic. It could be a latent poison pill bug, which gets exploited through traffic. It would protect all those scenarios if it happens. So that's what we are working on.
That's great. Abhishek, you've hit on two of the big three here. So we talked a lot about deployment safety and how we're trying to prevent from getting into that position. We talked about reducing the blast radius through some of that kind of sharding.
Right.
I'd love to hear more about, assume that that doesn't help, or assume that we still get into a bad situation. That third category of repair items is about being able to recover more quickly.
Yeah.
What are we doing in that space?
So we have made, after October 9th, we were looking for a short-term fixes that we could release. So we completed that short-term release across fleet, which takes our 4.5-hour recovery to close to 1 hour, 1 hour, 5 minutes, 1 hour, 15 minutes, like between that time. Some of the, like, the heavier the racks would be able to come faster. So we were able to reduce more than 3 hours in recovery time almost immediately. We are making next set of investment that would take the same recovery time to under 15 minutes. We could go much lower on that. So that's another set of investment we are making. And again, we are making in our proxy, we are doing almost a brain surgery where the config we are taking as a memory mapped config. So the processing it does, and when the data plane comes up, it can just swap to a memory that's like, having the config loaded. And that makes it do things that fast. We are still having, like, growing the number of customers. So that's the 750,000 would go way more. But this is the technique would allow to keep our recovery time under 15 minutes always, or maybe shorter.
Decreasing the recovery time is great to hear, but one question I know a lot of customers have is about decreasing the propagation time, right? We talked about how our propagation times at the moment are a little higher than we would like them to be.
Yes.
And I know for some customers, for many operations, 45 minutes for things to propagate is frustrating.
Yeah.
What are we doing to bring that down even further?
Our promise is to, with this outage and in the name of safety, we will not impact the customer's ability to manage their Azure Front Door. So the investment we are talking about, we would gradually try to come back and then reducing the time. Investment like where we are having an isolated process doing the data plane processing would give us a good confidence that even if we are missing something, it will not impact the data plane. And once that set of investment comes, we would like bring down to a certain extent. Once recovery, we believe it's under control, we'll bring down furthermore. So our goal is to go fast as customer expects us, but go super safe, not slow, safe. And my commitment is to make Azure Front Door platform that's delivering on both the promises. So that's a temporary measure, and till it just, we do not want to have a third recurrence of the impact. And we know the exact investment that we are making would get us to have a confident manner to reduce that big time that we have introduced.
Abhishek, thank you for talking us through what we're doing in Microsoft and what you're doing for the service team to protect customers. What could customers have done? What should they do? Are there any best practices that would have helped at all in this situation?
Yes, we published the well architecture framework and best practices for Azure Front Door like scenario. Some of our recommendations for customers also who onboard to Azure Front Door have a variety of applications. Some are super critical applications. Every application is important, but like in a category, some may not be as critical than other. We recommend for those critical applications, have a failover strategy. Use one of the strategy we recommend, have a traffic manager profile fronting your origins backend, and if Azure Front Door goes down, it's a simple less than a minute switch, a simple chain that would let traffic flow directly to your backend. You are not having a WAF protection and for that duration of period, but your availability will be there in that for those critical applications. So that's one recommendation. Multi-CDN for super critical workload that aspire to be 100% SLA. We recommend multi-CDN approach as well. For our first priority super critical services on the front door, we would do active-active approach as well. Not to all first party, like some of them would be following the best practices of Azure Traffic Manager, fronting the backends directly as a failover strategy. But some critical services on active-active. So our recommendation is for this mode, it's a highly disruptive. And it cannot be done for all applications. Multi-CDN, there is a management overhead, there is a cost also involved, right? So those are the factors like a business needs to consider. But those are the few recommendations. In general, your application, you want to make sure it's resilient of availability issues. Your retry doesn't get blocked. We have seen some instances where the Azure Front Door is recovered, but applications are still impacted because they have given up on retrying. So it's good to have some back off, right? You may not want to try as aggressively as you were trying initially to avoid the retry storm and other challenges, but make sure you are not in a deadlock situation where you stop retrying, because then customer had to go and do manually recover those applications, which is again adds to the pain, which is already the front door being regressed is a super painful situation anyway, right? So those are the recommendations.
Yeah, thank you for explaining the few levers that are available to help kind of weather the storm even better here. That's great. Thank you, Abhishek. And I've saved my last question for my co-host, Sammy here. Sammy runs our incident communications team. So in addition to hearing about learnings from the front door side, do we have learnings from a communications perspective?
Yeah, I'd like to walk through what happened. And typically speaking, we put out a survey after our PIR, and I'll be the first to admit I haven't read everything from all the comments yet. That there's a lot of feedback, which is great. So thank you very much to all of our customers. One of the key themes that came through is that customers were upset about the delays in getting the initial communications out. And it was interesting because I think for this outage, this was probably the best we're going to do when it comes to human beings putting communications out. Typically, we communicate through Brain, which is our automated system that Abhishek mentioned as well. It has a strong service level indicator, and we say we're confident, and we communicate to customers through the portal, through Brain. But this, our Brain signals didn't fire, so humans were there. So within about just over 30 minutes, we initially published something on our status page saying we're investigating. As Abhishek mentioned, we thought it could be DNS or front door, and so we put out it could be DNS or front door. And 1 minute later, we were sending communication to the portal. Now, even though customers couldn't consume the portal notifications because they couldn't log into it, those webhooks would have still been firing, and the APIs would have been firing, and so on, because it's built on dial tone infrastructure. But we had problems there. I'll address in a minute. The challenge now that we had is we had micro updates happening, like things were moving very fast in the outage. And so we updated our status page very regularly, on average about every 12 minutes. When we saw that there were slight delays, when we made edits to that last known good, and we updated it, because of all the restrictions that the AFD team had put in, they said, this is delaying us uploading our own configuration by a few minutes, by 10 minutes. And so we communicated this, 10 minutes. We didn't send this to the portal because for customers who have thousands of subscriptions or hundreds of alerts, sending them a micro update may have been overwhelming. So we set portal updates to be kind of milestones, like, hey, these are the big milestones, typically every hour, and every few minutes we were updating our status page. And that way, customers didn't have to depend on the status page, they can get these updates. The moment that the last known good was available in all the edge sites and we had an ETA, we communicated this ETA out very quickly. I think Microsoft knew at the same time that our customers knew. And we said, I think it was going to be around 4.5 hours. We actually pushed it out a little bit as well because that last stretch was delayed. So, we got it wrong by about an hour, but we were transparent with what we knew to our customers. Some of the painful things that I mentioned, our service runs on something called AZNS, which is the Azure Notification System. This was overwhelmed with alerts. And so for some customers, even after mitigation occurred, they were still getting these communications saying, hey, this is the current status. It's going to be 3 hours from now. And it was painful for customers to say this is confusing. And it was our latent system still playing catch up, which took a while to flush everything out of the system. And again, some of the problems and the learnings that we have is when we have these global outages or these big impacts where we're communicating to pretty much all customers, for customers that have multiple subscriptions, it's very noisy and very spammy. And if you're using ServiceNow, PagerDuty, Opsgenie, which you can do, you can orchestrate those and so on. But if you're not, it can be very overwhelming. One of the repair items in there as well is that Brain is going to be working with the Azure Front Door team, which means we can be able to auto-communicate. So hopefully that, even though it's 30, 40 minutes to get the initial communication out, we don't want humans to be involved. I was involved in the incident, so we had a great comms team going out there and doing things. but provided there's humans, there's always going to be latency. We can tell a good story, but we're not good at telling it very quickly. And that's where automation plays a key role. And the other learning is for a lot of customers, our support channels were down. Abhishek mentioned that they leverage Azure Front Door as well. They protect against DDoS attacks. They're publicly available to the internet. And they have failover strategies, but they weren't invoked fast enough. That muscle can atrophy over time. And so there are learnings to sit down to put the right systems in place to make sure that they can readily fail over. So for our customers, it was still painful, but we tried to keep them as updated as we could throughout the entire breadth of the incident. And even afterwards, when we had those restrictions in place, we told customers as well there are restrictions in place, and we tried to offer an ETA the minute we got one from the Azure Front Door.
I want to add one more point out there, and that's shows how the internal brain system works. So Azure Front Door, for example, when it's receiving a error failures in its data plane, this signal gets fed to brain, and if regression in those, it's automatically communicated to the customer. In this case, since the entire data plane itself is crashing, so those internal error rate signals were not there. We had a top level monitoring that's telling you have a major problem. So we could do the auto declare outage, but not necessarily the auto communicate to the all subscription. But that's not something that we don't want to fix. So as a repair, we are taking a fix where we will ensure a snapshot before the kind of traffic we are serving for those edge locations. And based on that historical data and combination, try to have that auto communication along with auto declare outage to come to shorten some of those times.
We'll be working with you closely on that, Abhishek.
Thank you for watching this Azure Incident Retrospective. At the scale of which our cloud operates at, incidents are inevitable. Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure Well-Architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.